How the human ear works. The outer part of our ear, or pinna, collects sound waves. It faces forward and has a specifically designed structure of curves helping us to determine the direction of sound and emphasize frequencies used in the human speech. Now that the sound waves are caught, they travel through the ear canal and strike against our eardrum, or tympanic membrane, a thin membrane about 10 mm wide. Now that we receive the sound, the middle ear transfers this energy. The smallest bones in your body, the malleus, incus and stapes, start in motion. The malleus is attached to the eardrum, and as the sound travels along the auditory canal, force is amplified by leverage until it arrives at the stapes, which acts like a reverse piston, creating waves in the fluid of the inner ear. The most significant increase in pressure is caused by the pneumatic amplification. The face of the stapes has a surface area of 3.2 square millimeters, while the eardrum has a surface area of 55 square millimeters. Using this, along with the leverage through the malleus and incus, the final pressure is 22 times greater than when the sound first arrived. Now we come to the most complicated part of hearing, the cochlea. In reality, it is coiled up, but is easier to understand and straightened out. There are actually 3 chambers inside, but let's take a look at the central part. The stapes is causing pressure waves to travel through the structure. Along the inside wall is about 20 to 30,000 reed-like fibres. As the waves move along, they encounter fibres with the correct resonant frequency and energy is released. These fibres aren't actually what gives us the signal that we heard something. There is a special structure called the semicircular canal next to these fibres, containing hair cells. The liquid inside this structure sloshes around and resonates the hair fibres, which then sends an electrical impulse to the cochlear nerve or auditory nerves and onto the brain. Certain pitches of sound will resonate in specific locations, and louder sounds will cause more hair cells to move. Our brain interprets all this raw data, making it possible to enjoy things like music or engaging conversation.